All right. So on the normal curve, which number is the mean in the standard deviation? These numbers on the bottom are the standard deviations. Which one is the mean? 0. 0 will be the mean. I'm going to write an X bar into there. When you get problems, and I'm going to say this over and over, when you get a problem asking you about a normal distribution, you guys should be drawing this curve on your paper, and then you'll be able to plug in numbers on the bottom like I'm going to do in a second. So like I said, we're going to use those percentages in there, and we don't have to figure out quite as much as we did the last time. So just for example, let's find the percentage of a normally distributed population that lies within 1 standard deviation of the mean. What does it mean to be, I'll flip back here, what does it mean to be within 1 standard deviation? Just between 0 and 1? Is it the only way I'm within 1 standard deviation of the mean? Yeah, there's -1 also. So I'm looking for anything in this range. I could be within 1 standard deviation going down, and I could be within 1 standard deviation going up. So what percentages do I have? Percentages now. Yep, 15.0. It's 19.1. We're going in this range. Within 1 standard deviation. 9.2 is going to be 1.5 standard deviations away from the mean. See? So we're going within this blue range. So we have 19.1. What's the next one? Oh. We got 15. We got 19.1. We got another 19.1. And then another 15. So take a look. We're within 1 standard deviation, right? So from -1 to 1. So this one, this one, this one, and this one. We're between our, okay? Just add up every percentage that you see pretty much from whatever range you identified as the range you want to do. That's once. And so what percentage do we have? If you add them up. Come on. 68.2% of the data of a normally distributed population, any normally distributed population lies within 1 standard deviation of the mean. Okay? Be careful when you're reading this chart, just as a side note. Notice the first 2 lines are not -1 and 1. They're -0.5 and +0.5, half a standard deviation. So when they ask you for 1, this will always be a choice, but your answer would be this one. Just be conscious of your scale, pretty much. All right, let's try another one. Don't worry about B. Let's try to see between 1 and 2 standard deviations above the mean. Where's between 1 and 2 standard deviations? Between 1 and 2 above the mean. From +1 to +2. Ooh. 9.2, 4.4, comes up to 13.6% of the data. Yep. So the real key to these problems is figuring out where your range is, just interpreting the question and saying, okay, I'm between 1 and 2, I'm within 1. And if you can do that, you're pretty well, you're going to be able to just pick up percentages and add them up. I'm confident you guys can add up percentages. So when we're given like a real data and a real problem, as opposed to one of these where we're just saying, okay, in a general population, we have to plug in the numbers on our sheet. So let's take a look at here. Let's take a look here. 424 juniors took the SAT exam, okay? On the math portion of the exam, the mean was 580 with a standard deviation of 80. scores were normally distributed. First, before we do anything else, what is the key words here? Not with. It's telling us about the population. The scores. It's telling us about them. Normally distributed, yeah. Normally distributed. Highlight it, circle it, whatever it is. If the problem does not say normally distributed, none of this can be used. You can't use that normal curve if it doesn't say it's normally distributed. Do you have a question? Two slides, yeah. If it doesn't say normally distributed, you cannot use that curve unless it says it. But it says it here. We're in luck. All right. We're going to find the percent of math scores between 580 and 660. Okay? So we do between 580 and 660. We look here. We see the mean was 540. We see the standard deviation was 80. We're going to come. You guys will probably need some scrap paper or your notebook if you don't take these in the calculator. What you're going to want to do is for each one of these problems, draw out this normal curve. Draw it out. Put the lines in. -3, -2.5, -2, all the way up to 3. Okay? Every time you see one of these problems, yep. All right. So, we know the mean score is 540 with a standard deviation of 80. First thing, I was given the mean. Where do I put the mean? In the middle, on 0 standard deviations. So our mean score here was 540. 540. Okay. Let's plug in. The next thing is 0.5 standard deviations above the mean. Now it said, remember from the other slide, it said my mean was 540. It said my mean was 540, and it said that my standard deviation was 80. So what is, for 0.5 standard deviations above the mean, how am I going to find that out? We're only going 0.5 standard deviations, yeah? We're going to use them in a second, but right now we're labeling what these are. Multiplied by point. By 0.15. We're trying to find for 0.5 standard deviations. We're not looking, yeah, guys, we're not looking at the percents right now. We're just trying to fill in the bottom of our table. So we're just looking for 0.5 standard. How would I find out what is 0.5 standard deviations? If one standard deviation is 80. 40, yeah. What do you do? Just, yeah, multiply by 0.5 or divide by 2, whatever it is. So 0.5 standard deviations is 40. What's 0.5 standard deviations above the mean? 80, I don't know what. 540 plus 40. So you get 580, exactly. 0.5 standard deviations is 40. We multiplied 80 times 0.5, we got 40. To find 0.5 standard deviations above the mean, we add 540 plus 40 to get 580. What about for one standard deviation? 620. How'd you get that? Yeah. Now we know each step is a half of a standard deviation. So we know each step is 40 pretty much. So we can just keep going up 40 each time. So the next one is 660, 720, or 700 and then 720. Yep. Sorry. Yep. And what about going down? Subtract 40, so we get 500. Yep, one more. Okay, 420. All right. So we wanted to know, go back, I don't want to lose the ink. What do we want to know in the thing? Find it. So we want to know the percent between 500 and 660. So we're going to go from negative 0.5 to 1.5 because those are where I have those two numbers. And I'm just going to add up all the percentages in between. What do I have? Careful. 19.1, 19.1, 15.0. We're going one, yep, 9.2. We're going from here to here. So this percentage, this percentage, this percentage, this percentage. We add them all up, and what do we get? 62.4%. 62.4%. Now it also wants to know how many actual people are this. We know 62.4% of the people. Part B asks us how many people is 62.4% of people. How do we go about converting that? We don't even need the normal curve really if we know this. Part B we're on. Okay, how many scores? How many people? Yeah. Okay. Scores. Each person got a different score, right? So we know it's 62.4% of the scores, right? How many actual scores is that? How can I get rid of the percent? Not divide. Multiply. You know, I can't multiply 62.4%. I need to what? Change it to a decimal, so I get. Change it to a decimal. Yeah, you gotta move the decimal. 0.624. Yep. And I'm gonna multiply by what? What am I gonna multiply? In general, if I'm given a percentage, what would I multiply by to get the number of things? Multiply by the 424. Yeah, the total scores. It said in the beginning on the slide, which I don't want to flip to because I don't want to lose my ink layer. It said there's 424 scores. 424 total scores. So 0.624 times my total scores of 424, and that'll give me what? 264.576. Okay, 57, whatever. We have to round this to 265 because you can't have half a score. You have a full score. So 265 scores are between that range. Okay? Not too bad. All right. Now let's take a look at this with the same situation. If Rose scored a 740, what percent of students scored better than her? So we're going to go back. I did lose my ink layer. Where were we? This was 540. 620. 660. 700. 760. All right. Plus 40. We're going up 40 each time, aren't we?
Yeah,
Oh. Okay. Yeah. This is 740 and this is 70. Yep. Okay. So she scored a 740. That means her score is where? Her score is where? So right on the line here. Right on the line at 2.5. Because 2.5 standard deviations is exactly 740. So her score is there. So what percentage of scores are above that? 0.6. This percent and this percent. 0.6% of scores are above her score. In general, when they're asking you a question about a specific point, it should match up right on the line of one of your standard deviations, and then you can look at it. And I highly suggest you draw that line in there and just see it. Okay? Yes? All right. All right. Remember, when we're calculating the percents like we've been doing, we're also calculating a probability. Probability is a percent. So I could have said, instead of just what's the percentage scores that are between 580 and 660 or whatever it was, could have said, if I have these 424 people, what's the probability if I pull out one of them that he gets a score between 580 and 660? It's the same thing. It's that percentage, that 62.4, whatever it was, percent. So let's see here. Here we have biologists are studying the weights of red king crabs in the Alaskan waters. All right, they sample 16 of them, compile their weights, and we get these. And we want to find the mean and the standard deviation first off. Go ahead and do that on your own. You should remember this. This is the homework pretty much from last time. All right, so you plugged in your list and spreadsheet. You went to the stat calculations, blah, blah, blah. You got that readout on your calculator page. What do we get for the mean? What do I symbolize the mean with? X bar. X bar, and I got 12.6 pounds. Remember, try and label these if you can. Also now, what did I get for my standard? Which standard deviation did I use? Sample. It said sample in the problem. If it doesn't say sample, you're using the population. But in this problem, it said on the previous page, it said we took a sample, which means we're using which symbol? S sub x. And it was? So 1.5 pounds. I'm going to round these to the nearest tenths. The data was rounded to the nearest tenth. All right. So we have the mean, we have the standard deviation. What do these values indicate about the data being, is it well modeled or not? Why would it be well modeled or not? What do you think? What's it mean for the data to be well modeled? What do you think, John? Well, so if I model something well, it means it's giving me like a good picture of what to do, right? Or what, like they say, like teachers will model something for the students and they do it themselves. So if I model it, if I take a sample, it's giving me a model of the population, right? So if it's well modeled, it means that the sample is going to be a good showing of what the population is. Well, how can we look at this and see that it's well modeled? Take a look at the standard deviation. Is it a big number? Not really. It's pretty small. So what does it mean if the standard deviation is small? What? Well, yeah, it's going to be easier to plug into calculation, sure. But what does it mean if I have a small? What does standard deviation represent? How what the data is? Kind of. Kind of. Remember, it's a measure of dispersion, right? It's a measure of dispersion. So it measures how spread out the data is. If I have a small number, how spread out is the data? Not very spread out. So if it's not very spread out and everything's pretty clustered together, that gives us a good model. If it was all over the place, how can we tell anything from it? See what I mean? Yeah. So that shows, that's another way of showing that it's a good model. But we don't always have, but the way the calculator works, we do, but if you're calculating these out, you don't always have the population data. And the population one is kind of, it's an iffy number because we don't have the entire population here. So it's derived from a formula, so it's not always 100% accurate. But the more accurate, the lower this number is, the more accurate the population number will be. I still have, okay. All right. So knowing those numbers, you remember we got this mean of 12.6, we got the standard deviation of 1.5. If our sample calculations apply to the normally distributed population of these crabs, what is the probability that if I randomly drop a fishing line in the water and catch a crab, What's the probability it'll be between 9.6 and 15.6 pounds? What's the key words before I go any further? Normally distributed. Normally distributed. Normally distributed. So that means I can go to my reference sheet and I could draw it out. Okay? And as you guys are drawing it out, where am I going to put my mean? At the 0. The 0, I have my 12.6, my mean. My standard deviation is 1.5. So let me fill in the rest of these. Or go ahead, draw this out and fill in the rest of these, why don't you? I got my 12.6. What's going to be 0.5 standard deviations above the mean? Yep. And what is that? 13.3? 13.35? Okay, and what's one standard deviation above the mean? 14.1. 14. Come on. 14.1. 14.85. 15.6. Okay, I'm not going to go any further. What about going down? 0.5 standard deviations below the mean is going to be 11.85. One standard deviation below the mean. 11.1. What was the question asking? Which range? Want to know percent between what? So I don't lose all this. Okay, 9.6 to 15.6, right? Okay, so we got to keep going. 1.5? 10.35, and then 9.6. So my range goes from where to where? What standard deviation numbers? -2, +2, yep. What's the percentage I have in there? Read them off. 4.4, 9.2, 15.0, 19.1, 19.1, 15.0, 9.2, and 4.4. We add them all up and I get 95.4. 95.4%. Don't forget that percent. All right, and just so I don't flip back, what was the last question on there? Part B or D or whatever it be? Who's got it? So they want to know how many fish this is, or how many crabs. .954 times, what is it? Does it ask specifically for our sample? It's not. Forgot to put that number in too. Yep, but that was the sample. I just gotta look at the question here. Oh, yep. So it's yeah. So in our sample, we had 16 fish. So it wants to know how many of these fish in our sample. 15.26. So yeah, 15 fish. All right. Good job, guys. So like I said, your homework's page 25. Make sure you draw out these. It becomes so much easier when you draw these normal curves out and you just put the stuff on there. You see, I really didn't have to do any calculations except that one thing for the labeling. That's it. All right.